Okay. Now, okay, this is actually where we stopped. So I'm going to take one more example on integration. Okay, one more example on integration, and then we will solve other questions that has to do with application. Okay. So let's go there. So we have this. Remember, this is actually integration by parts. We've done integration by substitution. We've also done integration by parts. So this is continuation on integration by parts. So take a look at this question. Let's look at integral. Integral of 6x exponential raised to power what? 7 plus x plus 7 dx. Okay. Like I said, there are two things I need to tell us tonight that will help our knowledge and our understanding of how to solve a question like this. The first one is this, the formula. I want to break down the formula and reduce it. Okay, the first one, recall. So integral u dv. Okay, u dv equals to u v minus integral of v du. So I've been able to reduce the formula. Integral of u dv equals to u v minus integral of v du, or okay, or integral of u v prime equals to u v minus integral of v u prime. So either of these, you're good to go. So this is the first thing I want to tell you, reducing the formula. Okay, use either this. The first one is u dv equals to uv minus integral of v du. So take note of this, very important. Okay, now the next thing I want to say, very importantly, is that when a question is given, remember the question is equals to the left answer. So from here, okay, let's solve this question. We have integral of 6x exponential x to the power 7, so x plus 7, okay, dx. So class, let's follow the formula. So the formula is integral u dv equals to u v minus integral v du. So it shows that, okay, this is u and this is v. So I did this so that you can see from the formula, the left hand side, the question you are giving is actually exactly the left hand side of the equation. So you know, this is the left hand side, this is the left hand side, this is the right hand side. So here, okay, it shows that u is equals to what? 6x, and dv is what? E raised to power what? X plus 7. From here, we know that u is what? 6x, dv is what? E raised to power what? X plus 7. Now, from here, let's obtain our u du. Then from here, we can obtain our what? dv. So now, I mean our v. So from here, let's obtain our u prime. Remember, u is 6x. It therefore means that du Okay, du will be what class? 6. Du will be 6 because if you differentiate du dx is going to give you 6. Okay, then v means you are to integrate. You have to integrate dv. So integrate dv. Remember, dv is what? Exponential raised power 7 x plus 7 dx. So if you integrate this, our v will give us, okay, a raised to power x plus 7, okay, a raised to power x plus 7 divided by, remember, if you differentiate x plus 7, you're going to have 1 ln e, okay, ln e. Remember, this is what I want to say. Don't bother putting C1 here. Don't bother putting C1, okay? So here, since ln e is equals to 1, okay, I have to put this so that you can remember ln e is 1, okay, 1 times 1 is 1, so it therefore means that v is what? Also e raised power x plus 7. So from here, okay, I needed to show us, okay, but from here, take note that whenever you have something like this, except x maybe is more than 1x, that is when it can become maybe 2, 2, if this is 2x plus 7, this should have become 2 ln e, which should have become e raised by x plus 7 over 2. But you can see that this is actually 1. So take note of this. Okay. So class, the next thing we'll do, we'll now substitute into the main equation. Remember, we have u from here, we have uv minus integral v du. So what is u? Our u is what? Our u is 6x. So u is 6x. Okay, u is 6x. Then what is v? Our v is e raised power x plus 7 minus integral of what? Integral of v. What is our v? Our v is e raised power x plus 7. Then what is du? Du is 6. Du is 6. Then we put dx. So this gives us 6x e raised power x plus 7 minus integral of what? 6 e raised power x plus 7 dx. So this gives 6x e raised power x plus 7 minus, now let's integrate this. Remember, if you integrate this, this will give us 6. Okay, this will also give us 6 into what? E raised power x plus 7, then plus, okay, plus c. Okay, so take note of this. Now, what is common here? What is common is that, okay, 6 is common. 6 e raised power x plus 7 is common. So this is 6 e raised power exponential raised power x plus 7 is common into what? X minus 1 k plus c. So this is your answer. Okay, this is actually your answer for that integration. Okay, this is your answer for the integration. Okay, you've been able to integrate this perfectly. Now, somebody is asking, Esther, what if they give us something divided by? Okay, let's take one more question and then we'll go to application. Minus 1. Okay, yes, I factorized this. You know, there is 6x e raised to x plus 7. There's also 6e x plus 7, x e raised to x plus 7. So if you factorize, if you take this and this out, what will be left here is 6. If we take all of this out, what will be left here is 1. So we have this into raised power x plus 7 into what? X minus 1. Okay, so next, let's take another question. Let's call this one question 1. So let's call this one question 2. Okay, take a look at this question. Integral of 6x divided by 3x minus 7 raised to power 3 dx. The first question somebody is asking is that, essay, how do I know that I'm supposed to use integration by parts? Why not integration by substitution? Okay, now class, anytime you're given a question, remember what I told you. If you are to take a look at this, if you say let u equals to 3x minus 7, if you find du dx, you're going to get 3. 6x divided by 3, you have 2x. So x is still left in your answer. Therefore, you cannot use integration by substitution. Okay, you can't use integration by substitution. So what do we do? Okay, what do you do? See what I'm trying to explain to you. See what I'm trying to explain. For instance, if you say let u equals to 3x minus 7, du on dx will give us 3, right? If this 3 is used to divide the 6x on top, okay, over 3, you're going to have your answer as 2x. Because there is 6x in your answer, okay, you cannot use integration by substitution. But if this was, let's say this was 6, and you said 6 divided by 3, you have 2, and there is no x in your answer, then you can use integration by substitution. So in this case, we cannot use integration by substitution, but we can use integration by part. Now, what's the next thing you're supposed to do? A question like this requires that you have to be very smart. The next thing you do is this: linearize it, standardize it. That is, this will become integral of what? 6x into what? 3x raised to minus 7 raised to what? Minus 3 dx. Okay, remember our formula? Our formula is integral what? Integral of u dv equals to what? uv minus integral what? v du. So what is our u is what? Our u is 6x. Then our dv is what? 3x minus 7 raised by what? Minus 3. So let's find du. Our du dx, which is written as simple as du, it will give us 6. Now let's find v. To find v, integrate dv. And that is telling you have to integrate. You have to integrate 3x minus 7 raised to power minus 3 dx. So now let's integrate this. Now class, in order to integrate this, very, very importantly, in order to integrate this, you will use integration by substitution. Use integration by substitution. Now, what am I trying to say here? What am I trying to say? This part, let's integrate it, okay? So we are integrating. So we have 3x minus 7 all raised to power minus 3 dx. So class, integrate by parts. Sorry, integrate by substitution. Integrate by substitution. So the answer will bring the answer back. So here, if you're integrating by substitution, quickly, you can say, we can use something else, but of course we are used to you, but I don't want that you to confuse you with this you. Okay, so let u be 3x minus 7. Okay, so here we have du on dx will give us 3. Therefore, dx will give us du over 3, right? So what you need to do now is to replace it in the original integral. So this will be integral. Okay, this will be integral of what? U raised power what? Minus 3. And what is dx? The x is du over 3. Okay, and that gives us, so now let's integrate this. Okay, remember, let's take this out. This is 1 over 3 integral of what? U raised power minus 3 du. So integrate this. This is 1 over 3. Okay, u raised power minus 3 plus 1 divided by minus 3 plus 1. Remember, don't bother putting the c. So this will give us 1 times this will give us 1 over 3 into what? U raised power minus 2 over what? Minus 2. So we have u raised power what? Minus 2 divided by minus 6. So we now say, okay, but u is what? U is what? 3x minus 7. 3x minus 7. So instead of having u now, I'll now put 3x minus 7 all raised power what? Minus 2, okay, over 6. This minus comes up. So this is the integral, okay. That means the integral, okay, the integral of 3x, okay, 3x minus 7 raised power minus 3 dx, okay, will give this minus 3x minus 7 raised power minus 2 over 6. So this is what I'm going to bring. This result, okay, okay, is actually our v. Take note, this is our v. So our v, this is our v. Take note of that. That is our v. So I'll bring that formula, I'll bring this solution back into the formula. Take note of this. Okay, this is very simple, but you just need to calm down, okay, and watch exactly what I'm doing. Okay, now we've gotten our v to be this. So let's go back to our formula. So this is, so now says substitute, okay, u, v, okay, and the u into the formula, okay, into the word class formula. So, our formula, let's go back, we have u, v minus integral of what? V du. So what's our u? Our u is what? 6x. U is 6x. What's our v? Our v is minus into 3x minus 7 raised power minus 2 divided by 6. Remember, that is our v. The minus integral v is what? Minus, okay, let's have this, minus into 3x minus 7 raised power minus 2, okay, over 6. Remember, this is minus 2. This is our v. Remember, this is our v. Then du is what? Du is 6. So this is 6, then dx. So now let's take it step by step. Let's take it step by step. Now, okay, class, use this to multiply this. Use this 6 to multiply this. Let's go there. So this gives us, okay, minus 6x, okay, into x, 3x minus 7 raised power what? Minus 2, over 6, then minus integral into what? Minus 6 into 3x minus 7 raised to the power minus 2 over what class? Over 6 dx. So please calm down. Don't use this to multiply this yet. So 6 cancel 6. We have minus x, okay, into 3x minus 7 raised to the power minus 2. Then minus, 6 cancel 6. We have integral what? Minus into 3x minus 7 raised to the power minus 2 dx. So we'll now integrate this side. Okay, we need to now integrate this side. So the integral of this is very simple. The integral of this will become minus, this is minus x into 3x minus 7 raised to the power minus 2. Okay, then minus, okay, minus, open the rectangular bracket. Okay, we have minus, how do you integrate a question like this? It's very simple. Minus, okay, out there, minus 3x raised to the power minus 7, minus, open bracket 3x minus 7 raised to the power minus 2 plus 1, okay, divided by what? Minus 2 plus 1. But you know that there is this 3x, you need to also differentiate it. That will give you, okay, that gives us, okay, over what? 1 over 3, okay, 1 over 3, we've already done this. This is 1 over 3, okay, plus c. So this is where you now finally put the c. So we have minus x into 3x minus 7 raised to the power minus 2. Okay, minus, so let's go there, open bracket. This is minus, open bracket, 3x minus 7 raised to the power minus 1. Okay, divided by what? Minus 1 into what? 1 over 3 plus c. Okay, so take note of this. So you can see, as I said, don't multiply it. You can see the minus cancel this minus. Okay, so we have minus x into 3x minus 7 raised to the power minus 2. This is minus, because this minus cancel this minus. Then we now have 3x minus 7 raised to the power minus 1 divided by this 3 plus c. So now let's go there. Is there anything we can do? Yes, we can factorize. We can factorize. Okay, if we factorize, okay, remember this would be, this is your final answer. But if you choose to factorize, okay, you can say 3x, okay, raised to power class, 3x raised to power minus 3 minus 7 raised to power minus 1, okay, into what class? Minus x. We have x, sorry, 3x minus 7 raised to power class. Let this one be rectangular bracket. Okay, minus 1. Okay, the minus 1 over 3 plus c. So this is what you're going to have, but preferably I'll prefer you stop here. So class, this is integration by substitution. Integration by substitution. Okay, now let's go ahead and look at some applications. So integration. At this point, if you have any question, kindly ask. Any question? Okay. So in the absence of that, now let's go ahead and sort out a few things. Okay, so we're looking at economic applications of integration. Is somebody asking question? Okay, in the absence of that, please let's mute ourselves.
I want to ask question.
Okay, go ahead.
Okay, please, this write-up that you used to solve, are you going to send it to us so that as
Yes,
listening to this thing, we might also be going through it?
I'll send it.
Okay, thank you.
Welcome. Okay, so let's look at economic applications of integration. So we have economic applications of integration. So the first one we're going to look at is actually investment. So let's first look at investment. Okay, let's look at investment first. Okay, class. Net investments, okay, is denoted by I and is defined as the rate of change in capital stock formation. The capital stock formation is represented as capital K over time T. So if the process of capital formation is actually continuous over time, then we'll say that net investment is a change in capital stock with respect to time. Okay, so let me give you a short note on that. Let me give you a short note on that. Net investment, so net investment is defined, okay, as the rate of change in capital stock, formation. Okay, K over time. Over time T. If the process of capital formation, is continuous over time, okay, is continuous over time, okay, then our net investment is equals to the K respect to what? The T, which is equals to K prime T. Now, class, from the net investment, please pay attention. All of this short note is very important. What is the application that matters? Okay, from the net investments, the level of capital stock, can be estimated. The level of capital stock can be estimated. Note that capital stock is the integral is the integral with respect to what? To time. Okay, is with respect to what? Respect to time. Respect to time. Okay, of net investment and it is giving us we have capital stock equals to integral. Okay, integral so we have dt, which is equals to k t plus c. Now class, this is also the initial capital stock. Okay, this is actually equals to, okay, the C there is actually the initial capital stock. The capital stock, okay, when T is actually equals to 0. So where C is equals to, where C equals to the initial capital stock. Okay, so let's take few questions so that I want it to make sense to us, all these things you are doing since. Let's take few questions and that will go a long way. Okay, now class, the rate of net investment is given us, this is PQ. Okay, we have question 1. They give us the rate. They said the rate of net investment is given by IC equals to 140T raised to power 3 over 4. And the initial stock of capital okay, at T equals 0 is 150. Determine the function for capital K, okay, capital K, the time part K. So now, remember we've been giving nets. Our net investment is, so take a look at this now. So let's do the solution. Net investment. Okay. Recall, so I has been given as 40 series power 3 over 4. You know, this is I. Okay. Remember, this is what this is actually our net investment. So recall, so let's recall that our capital stock at time t is the integral of net investment with respect to what? To time. Okay. So this gives integral of 4tt raised power 3/4 dt. So now let's go ahead and solve it. Let's sort it out. Let's sort this out. Okay. So k is equals to, remember, this can be, oh, is this 140? Sorry, is 140. 140. 140. I'm so sorry, please. It's 140. So I can bring this 140 out. Then we have integral of t raised power 3/4 dt. So now let's go there. This is 140. T raised power. Remember, if whenever you're doing integration, you add 1 to the power, then the sum of the power, you repeat it 3/4 plus 1. Okay, then plus c. So this gives you 140. T raised to power 4 times 1 is 4, plus 3 is 7. So that is 7/4 divided by 7/4 plus c. Remember, move by denominator, the 4 will go up, 7 stays down. So that will give us, let me help you guys out. So this is 140, okay, into t raised power 7/4. Remember this division line, okay, is what I have here, 7/4. So that you look as if I'm jumping. So this is 140 into t raised power 7/4 times 4/7. So when next I'm solving a question like this, and I said, if you have something like this, this 4 goes up to multiply this 7 stays down. This is what I'm trying to say. So 4 times 140, or you can just say 7 here 1, 7 here 20. 20 times 4 is 80. So this is 80 t raised power 7/4 plus c. Okay, so this is our KT. Now, a quick one. The question has said that, but remember that the question said the initial stock of capital at t equals to 0 is what? Is 150. So that's okay, but take a look at it. They say, but the initial stock of capital at t equals 0 is this. Remember, C is what? The initial capital stock or initial stock of capital. So, but C is equals to what class? C is equals to K naught, which is equals to 150. Remember, we are supplied 150. So you can answer, therefore, the function for capital, the function for capital K is, so K is now equals to 80t raised power 7/4 plus, instead of me putting C, I'll now put 150. So that is actually the function for the capital stock K. Okay, that's it. Now, let's take a question on cost function. Okay, on cost function. Remember what we just did is actually on investment function. This is on investment function. So let's do something on cost function. Class. Same thing applies to marginal revenue. Okay, don't forget that. Now, there's something I must say here, very, very important. Class, anytime anytime you are asked a question as, regarding integration, always take note that integration is the opposite of differentiation. Integration is the opposite of what class? Integration. So now on marginal cost. Okay, class, let's go there. We just did on investment. So let's did on cost. Okay, this is on cost. Okay, now class, take notes. Recall that under differentiation, okay, this is my highest volume actually. Okay, recall that under differentiation, okay, the C over the Q is going to give us, that is change in cost over change in quantity, will give us marginal cost. Take note of that. Whenever you differentiate total cost, you get marginal cost. Remember that. We get marginal cost. Anytime we differentiate total cost, we get marginal cost. But under integration, okay, when you integrate marginal cost, you obtain total what? Total cost. You obtain total cost. You see them? While the same, the constant there will not be our fixed cost. But I just want you to know that if you integrate marginal cost, you get total cost. If you differentiate total cost, you get marginal cost. Okay. So take note of that. Okay. Now we have given that marginal cost is equals to 25 plus 30Q minus 9Q squared. Okay. And fixed cost is 55. Find the total cost. Find the total cost. Okay, B, average cost. Find the average cost. C, variable cost function. All of this is functional. This is average cost function. Sorry, total cost function. This is average cost function. And then variable cost function. They are all function. So what do you do? Solution. Remember, to get total cost, I will integrate marginal cost with respect to what? To Q. So to get total cost, remember, our marginal cost is what? So that's why I want to go straight to the point. 25 plus 30Q minus 9Q squared the Q. So now we're going to integrate this now. So let's go there. How do we integrate? Remember the rules of integration. Let me use this to also throw more light on the rules of integration. So this, I can open the bracket with the integral sign and the Q. So this will give me, we have TC equals to the integral of okay, we have the integral of 25 the cube plus integral of what? 30 cube the cube minus integral of what? 9q squared the cube. So TC gives us, you know, if you are to integrate this, this will give you 25q. Anytime you are integrating a constant, you have that constant with the variable you are you are integrating with respect to. So plus this will give us 30 into q raised power 1 plus 1 divided by 1 plus 1, then minus 9 into what? Q raised power 2 plus 1 over 2 plus 1 plus c. So this becomes 25q plus 30 q raised power 2 over 2 minus 9 into q raised power 3 over 3 plus c. So this will give us 25q plus 2 here 1, 2 here 15, 15q squared, 3 here 1, 3 here 3, 3q raised power 3 plus c. So class, this is actually your total cost. We'll now say, okay, fine. Remember, they gave us that with what? They give us fixed cost to be what? 55. We now say, okay, but C is equal to fixed cost, which is equal to 55. That means, therefore, our total cost will be 25q plus 15q squared minus 3q raised power 3 plus 55. Okay, so that is our total cost. Now, how do you get our average cost? Okay, our average cost is when you divide total cost with respect to Q. So that will be all of this divided by Q. That will be 25Q divided by Q plus 15Q squared over Q minus 3Q raised power 3 over Q plus 55 over Q. So this will give us 25 plus 15Q minus 3Q squared, okay, plus 55 over Q. So this is our average cost. Then how do we get our variable cost? Remember, variable cost function is very, very simple. Okay, from here, all the one that carries Q from here up to this point is actually our variable cost. So that one is very simple. Our variable cost is equal to all the one that carry Q, 25Q plus 15Q squared minus 3Q raised power 3. This is variable cost. This is variable cost. Okay. Although the question went straight. What if the question did not ask you, okay, to find variable cost, and then you are supposed to find average variable cost? Maybe the question says find average variable cost. Remember, you cannot get variable cost without first getting total cost. Once you obtain total cost, then you can actually obtain variable cost. From variable cost, you divide variable cost by quantity, then you're going to obtain your average variable cost. Okay, any question? Any question, please? We're done with cost. Let's go to revenue. Okay, I wanted to say something that what if the question had asked you to calculate average variable cost, although it's not there, but average variable cost would have just been variable cost over quantity. And that would have been 25Q over Q plus 15Q square, okay, over Q minus 3Q raised by 3 over Q. So that would have given us 25 plus 15Q square minus 3Q, oh, sorry, 3Q square. So this is our average variable cost. Okay. Okay, so let's move on. If you're not seeing anything, possibly you have to maybe you should log out and log in again. Check your camera and check your login detail. Now let's go to revenue. So on revenue, remember to obtain total revenue, if you're given marginal revenue, you have to integrate marginal revenue with respect to Q in order to obtain total revenue. Okay, you have to integrate. If you're given, take note, anytime you're giving marginal revenue, integrate it, you get total revenue. So now let's go there. Let's take a question. Okay, let's take a question. Question 1 on this. Okay, given MR equals to 60 minus 2Q. All these questions are past questions. 2Q squared, because I don't want to waste time. That's why I'm going straight to the point. Okay, find A, the total revenue function, total revenue function, okay, nobody's in the waiting room, okay. B, the demand function, and that demand function, they said P is a function of what? Of Q. Demand function, and they say P is a function of what class? Of Q. So there. So we have so solution, we have, take note, you know, we've been given the marginal revenue, to be what? 60 minus 2Q minus 2Q squared. So what do you do to get total revenue? The A part, to get total revenue, please integrate marginal revenue with respect to quantity. So total revenue will be the integral of, put it in bracket, 60 minus 2Q minus 2Q squared dq. Now let's go there. Integrate. We are integrating. This will be integral of what? 60 dq minus integral of what? 2Q dq minus integral of 2q squared dq. So this gives us 60q. Remember, anything you're integrating a constant, this will give us straightforward minus 2q raised power 2 over 2, straightforward. This will give us minus 2q raised power 3 over 3 plus c. So we have 60q minus q squared minus 2 over 3 q raised power 3 plus c. So class, this is total revenue function. This is total revenue function. But class, it's very important you take note of this. So very, very important. Let's take note of this. But that's okay. That's okay. But at q equals to 0, we know that total revenue will be what? 0. And C will also be what? 0. Okay. So what is that trying to tell you? That our total revenue, okay, that's okay. Therefore, let me write it here. So we say therefore, total revenue will be 60q minus q squared minus 2 over 3 q raised power 3. Okay, that's our total revenue. Okay, I hope you're following. This gives you total revenue. Okay, the next question is the demand function. How do we obtain the demand function? So class, note, demand function can be obtained using total revenue equals to price times Q. Remember, your total revenue is what? Is when you multiply price with what? With quantity. When you multiply price with quantity, you get total revenue. Okay, so from here, we can find our price. So from here, P becomes TR over Q. Okay, P is what? TR over Q. And what is TR? TR is 60Q minus Q squared minus 2 over 3 Q raised power 3 divided by Q. So what it means is that divide each by Q. So this is 60Q over Q minus Q squared over Q minus 2 over 3 Q raised power 3 over Q. So this will give us 60 minus Q minus 2 over 3 Q squared. So this is the demand function. That's the demand function. Please take note of this. This is very important. And that is very, very crucial. Okay. So class, I'm going to send some assignment to us. Okay, which will definitely help us to know a lot of things. Now, let's go to definite integral. Definite integral. Okay, the definite integral. Bear with me, I am with you. So, okay, somebody want to ask a question? Vicky J, please ask your question.
Okay, you said you're going to give us assignments. I hope the videos will be sent so that we will know how to solve, because it's as if you are a little bit too fast.
Okay. Number one, in fact, for this class, I have to take it slowly, extraordinary slowly, because I noticed that a lot of you that have connected to the class have not done integration with me. You may have done it before, or possibly you may have read or studied integration, but maybe not to this extent. Okay. Some of the students here started this class with me, so they can flow with me and they know what I'm doing. But few of you that just joined the class, especially for the this month of June, have not done integration with me. So I'm going to take it more slowly again. In fact, I'll go more slowly so that everybody can catch up. Then I'll send you the notes. I'll also send you the video to back it up. Okay. So please just try and follow up. Okay, the video will help you to actually catch up on time. Okay, so let's move on, please. Now, let's go to the definite.
Thank you.
You're welcome. The definite integral. Let me start from new page. So we're looking at the definite integral tonight. We have been able to sort out a lot of questions under integration. Now, class, anytime you hear indefinite integral, what comes to your mind is that your answer must be in form of functions. But when you hear definite, something that is certain, you are sure to get a particular value, a particular number. So for the definite integral, take a look at this. Okay, given the integral of a, b, such that you have f of x with respect to x, which equals to f of x, a, b, which is equals to f of b minus f of a. Now, what is this telling us is that this is upper limit. This is upper limit, and this is lower limit. Okay, I'm just teaching this for the first time. Okay, now what happens is that once you integrate normally, just do your normal integration the way you do it, then you now substitute the value at b, the upper one, minus the value of a at the lower one. So that means you get a simple value. So let's go straight to the point. There's no point to waste. There's no time to wait. Example 1. Let's say you're given the integral of, this is 4 and 1. You have 5x raised to power 3, the x. So see what we're going to do. Let's use this example. So solution. So we use this to also learn integration as well. For those who are just joining for the first time, this is how to integrate. So what you do first of all, integrate normally. So this will be, we have the integral of 4, 1, 5x raised to power 3, dx. So this is what you're going to do. This 4 and 1, suspend it. Focus on 5x raised to power 3. So how do you do this integration? This is 5. The x is raised to power 3, Abi. Write it, right back the question. Then you now add 1 to the power. repeat everything over whatever you are having here. You know, you said 3 plus 1. Repeat that 3 plus 1 down. 3 plus 1. Repeat it down. Then plus C. Do you understand? So this will give us 5x raised to the power 4 over 4 plus C. That is your normal answer, Abi. Now, but you have to substitute at 4 and 1. Okay, you have to substitute at 4 and 1. So I'm substituting at 4 and 1. So this will now be, anywhere I see x, I'll put 4. Let's first do for 4. This will be 5x, x raised to the power 4, I'll put this 4, raised to the power 4, divided by 4, plus C. I'll close the bracket. I'll now say minus the same function that I got, substitute at 1. Okay, open the bracket. This will be 5. Instead of me putting S, I'll put 1. Okay, 1 raised to power what? 4 divided by 4 plus C, close the bracket. So this will now be 4 raised to power 4 is what, class? Somebody has done it? 4 raised to power 4. Okay, class, this is supposed to be 464 times 4. So 64 times 4, 4 times 4 is 16. 4 times, that should be 256. Right? That should be 256. So, okay, 256. Okay, now this 4 will cancel one of these 4. That will be 64. 64 times 5 is what, class? 64 times 5. 5 times 4 is 20. 5 times 6 is 30. That's 320, right? Okay, so thank you, Abigail. That's 320. That's 320 plus C. So this is this side. This side alone, 320 plus C minus, let's do this side. 1 raised to power 4 is 1. 1 in 4 places is 1. 1 times 5 is 5. 5 divided by 4. 5 divided by 4 is what? 1.25, if I'm correct. Okay, correct, 1.25. Thank you. That is 1.25 plus C. So now let's go there. This will now give us 320 plus C. Use this minus to open the bracket. You see that the C will disappear. This is minus 125. Oh, that minus 1.25. Then this minus cancel, multiply this plus, become minus C. So plus C minus C has cancelled. Class, in your answer, in your final answer, you can never have a C. You can never have a C in your final answer. So whenever you're doing definite integral, you must have a value as the final answer. So 320 minus 1.25, Abigail. 320 minus 1.25. So that should be what? Is somebody helping us? $320. Okay, we have 318.75. So this is your answer. This is your answer. This is your answer. Okay. Now, class, let's take one question. Let's take one question again. Let's take one more question. This is example 2. Okay, integral. You're giving integral, they gave you 2 here. This is 0. Okay, so you're giving 4 cube e raised to power q square the q. So this question is very simple, but take a look at what I'm about to do. This question, we cannot solve it normally. We have to use integration by parts. Okay, solution. Okay, use, integration by substitution. Use integration by substitution. Q square definitely will give us 2q. 4q divided by 2q, we only have a number there, so you're good to go. So that means you say let u equals what? Q square. The one on top of e should always be your u if you're having an exponential mixed with a number. So it means du dq will give me 2q. Then make dq the sort of formula. Dq will now be du over what? 2q. Please, I'm sorry, I'm going to extend your time. I'll extend your time maybe with 10 minutes, please. Just give me extra 10 minutes. So we have, so go ahead and substitute. So this will now be integral. Remember, we have our, okay, remember, don't, this one 0, suspend it. We know whatever we're doing. So this will be 4q. Then e raised power what? U, because u is q square. Then the q is what? Is now du over 2q. So my dear friends, 4q divided by 2q, it will give me just 2. So this is the integral of 2 e raised power u du. Remember, if you integrate to e raised power u, it still gives e raised power u. So this will still give us, this will still give us, this will still give us 2 e raised power u. So we now say, okay, but u is equals to q raised power 2. So plus c. Remember, at this point, you should add plus c. Okay, if you like, you can add. If you like, don't add. So this will be 2 e raised power what? Q squared plus c. So and now I'm now substituting at what? At 2 and 0. It is when you are done with the integration that you now put this. So I will say, I will now do, okay, 2 e raised power what? 2 square. Okay, 2 square. Remember, q is plus c. Then minus open bracket 2 e raised power what? You know, when q is 0 square plus c, close the bracket. I'm sorry, I'm supposed to put this in bracket. Okay, this is supposed to be in bracket. Let me do it. Whatever is what doing, I thought it's what doing well. Okay. Okay, that is 2. So this will be, okay, this will be 2e raised power 4 plus c minus 2e raised power what? 0 plus c. Okay, so class, let me press e raised power 0 in your calculator. E raised power 0 is 1. Then e raised power 4 is what, class? Can somebody help me? E raised power 0 is 1. Thank you. E raised power 0 is 1. Then what about e raised power 4? E raised power 4 is what? E raised power 4 multiplied by 2 is what? Can you all do it? Okay, because of time, I'm trying to get my calculator as well. Just press E, raise power 4 in your calculator, press equals to multiply by 2. Oh, are we saying we cannot achieve this? Please give me some time. Let me quickly check for my calculator.
It's 50.
So this is what you do. This is what you do. Take a look at this. This is your shift. This is your alpha. There are two ways to get E. Okay, the first one, press this alpha. You can see that alpha A is showing us alpha. Then come and press E. You can see E. Can you see E? Press it. Then you can see E is actually, can you see E is blinking? The next thing you do, you press raise to power. Then you put 4. Put your 4. Okay, press 4. Is there. Press equals to. This is what you have. So somebody got it 54 point. So multiply by 2. You have 109.196. So 109.196. Okay, so we have 109. Thanks, guys. 109.196 minus this one is 2 plus, oh, sorry. So this is 109.196 plus C minus 2 plus C. Okay, remember this plus will cancel this. This will have 109.196 plus C minus 2 minus C. So this plus C cancel this. So this will give us 107.196. So that is the answer. So for definite integral, you must get one value. You must get one value. Okay, thank you. God bless you. Okay, like I said, please pardon me. I need to extend your time. Please hold on.
I can hear you. I can hear you.
Okay, yeah, I had to pause the recording.
Hello?
If
Please, can you hear me?
I can hear you. I said I had to pause
I
the
can hear
recording.
you, sir. Yeah.
Yes, I said I had to pause the recordings because I
Okay.
don't know your question. So I want to ask you, is your question based on what we just solved or based on the classes, I mean, the people that are taking your courses?
It's actually based on what we've just solved, though not the same question.
Okay, don't
Not
worry, don't
same
worry.
question, but I came across.
Hold on, let me record it. Since it's on based on the class, let me record it.
Under application. So I came across one question that I'm not able to solve. Using integration to get consumer and producer surplus.
Okay, it is under,
Yeah.
That question is under definite integral. Okay.
Yes.
Exactly.
Yes.
Yes, exactly what we did is what you're going to do. So you know what? In the next class, please remind me or chat me up. In the next class, we'll do something on consumer surplus and producer surplus. Okay.
Okay, we can't do it this night.
No, I've already written differential equation. What I want to take, I don't want
Okay.
to carry it over.
Okay, no problem. No problem.
Thank you. Yes.
Yeah.
So now let's go there on differential equation. So class, we said a differential equation is a mathematical equation for an unknown function of one or several variables that relates the values of the function itself, okay, and of its derivative of various orders. Okay. So example is, let me give you an example of differential equation. Okay, let me give it to you because some question may ask you to define it. A differential equation, okay, is a mathematical equation for an unknown function. For an unknown function. Okay. Of one or several variables that relate the values of the function itself, okay, and of its class, and of its derivatives of various orders. So let's take few example. Okay, let's say examples. Okay, example of differential equation. Okay, something like this, dy over dt minus 5y equals 0. Okay, number 2, y prime prime minus 8y prime plus 10y minus 11 equals 0. Let's take another one. If you have the y over dx equals to x squared plus 3s is also an example of what? Differential equation. Okay, so class, let's go to order and degree of differential equation. Order and degree of differential equation. Okay, so let's go to order and degree. So this is order and degree of what? Differential equation. So let's start with order. Let's start with order. The order of a differential equation the order of a differential equation are following. The order of a differential equation is the order of the highest derivative. Okay, thank you. The order of a differential equation is the order of the highest derivative in the equation. So let's go straight to the point now, class. Now, if we have something like this, example, if we have something like this, the 2y over the t square minus the y over the t plus 4y equals to 0. Take a look at this now. This one means that this thing has been differentiated once. This one is 1, this one is 2. You can see the power here is 1. So you look at this equation. Which one has which is the highest order? D2 dy is the highest order. There's dy, this is first order, second order. In this equation, which one is the highest order? Is the 2y. So here, the 2y is the highest order. So here is second order here. Here is second order. In this case, is second order. Okay. Now, this is example 1. So this is second order. Okay. I'm coming somewhere that's second order. Okay. Now, example 2. Take a look at this, class. We have dy over dt minus the 3y over the t cube plus the 4y over the t4 minus 3y equals to 0. Class, what is the highest order here? The highest order here is what? Is 4. This is first order, third order, fourth order. So the highest order here in this equation is what? Fourth order. Fourth order. Now, this one is okay. Let's go to degree. Let's go to degree. Now, class, the degree of a differential equation, the degree of a differential equation, is the class, is what class? Is the highest power, to which the highest, take note, is the highest power to which the derivative of the highest order is raised. The degree of a differential equation is what? Is the highest power to which the derivative of the word highest order is raised. Highest power. Okay. The differential is what is equation. The degree of a differential equation is the highest power to which the word derivative of the word highest order is raised. Now, you know, here the highest order is 4. Here the highest order is 2. Now, whenever you look at the equation, ask yourself, which is the highest order in that equation? You will now ask yourself, the highest order, what power is it raised to? The highest order, the power, the highest order in any equation is raised to determines the degree. So if I know that the 4y over the t4 is the highest order, that means I'll now go and check what is the power. Since the highest order here is 4, this 4 will now determine where I should check my degree. And in checking the degree, I will check the power on this. In this case here, The power here is 1. This means raised power what? 1. Okay. So in this case, this would have been 4th order first degree. Don't worry. Let me give you another one. Let's take an example. So because this one is coming out, cannot miss it. So let's take example. So we have, let's have it as classwork number 1. Class, we have, take note of this. We have a very good example that I want to give you. We have the 2y over the t square plus dy over dt all raised to 3 minus 10t square equals to 0. Class, what is the highest order here? What is the highest order?
The 2y.
Thank you. That means the highest order is what? Is 2, right? The highest order is 2, right?
Yes.
Thank you. So this is second order now. This is second order. Now, the second order, since this is highest order, what is the power on this second order? What is the power? This, whenever you see something like this, it means the power is what? It means the power is 1.
1.
Yes. So this is second order first degree. Second order first degree. Let me give you another one. Let me give you another one. What about this? The 5y over the x 5 raised to power 9 plus the 6y over the x raised to power 6 minus 5t squared equals to 0. Who can tell me the order and the degree?
The highest order is 6. That
So
is the 6y. Why the highest degree is 9? The 1 raised to 9.
No, degree 1 now is 1.
Degree 1, I know. Degree 1.
Okay, I thought you said 9.
okay, so that's correct.
Highest
This
order
is
6 now. Degree 1.
Yeah.
Yes, degree. So this is 6th order.
Degree 1.
First degree.
Yes.
Don't make mistake. Oh, this is to confuse you. You know the highest order here is 6. Don't go and, you know, this is 5. 6 is greater than 5. Don't go and choose degree 9. No, the highest order is 6. Therefore, since this is the highest order, the power it raises to is the degree. So this is 6th order first degree. Let me give you another one. Let me give you another one. This one will make you happy. What about this one? The 2y over the t squared minus the 2y over the t squared all raised power 3 equals to 105y. Who can tell me the order and the degree?
Second order
2.
degree.
Degree 3.
3rd degree.
Correct. This is second order. Very correct. Second order, 3rd degree.
3rd degree.
Very correct. Number 4, let's take this one. Thank you, Abigail. Let's take this one. How about this one, class? Y prime prime. This prime prime means twice, which is second order. Y prime 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 3rd order plus y prime prime raised to power 7 minus 32 y equals to 0. Who can tell me the order and the degree?
3rd order. 3rd order.
Mm-hmm.
1st degree.
Correct. This is third order. You guys are very good. Third order, first degree. I like that. I like that. Third order. Don't go and look at 7. No. Thank you, Michael. God bless you. Third order.
Please, I want to ask a question.
Please go ahead.
Okay, this thing is seems it's my first time of actually coming across it. So I want to know how this order is arranged to know which one is the first order, the one that is second, and the one that is third.
Okay, Vicky.
I understand the definition of order and degree.
Okay. Now, to know,
but I don't know how it is arranged.
To know order, say, you know, this is 1, 2, 3. This is third order. 1, 2, second order. The highest order in this equation is 3. Okay. 1, 2, 3. Third order, correct? Okay. Then how do we now know the degree? It is the highest order. It is the highest. It is the power. The highest order is raised to that defines the degree. So that means if this is the third order, what is the power is carrying is 1. So this is third order first degree. Let's go here now. Let's go here. This is D2. This D2 means second. This D2 also means second. But how do we define the degree? You will not check the power. The power here is 3. The power on this one is 1. So this is second order third degree. Let's go to this one now. This one is the 5y, the x5. The 6y. So that means this is 6. 5. 6 order. 6 is greater than 5. 6 order. The power on this one, Vicky, is 1. The power on this one is 9. So somebody may confuse and say, since 9 is greater than 1, that means 6 order 9 degree. No, it's wrong. The highest order is 6. Therefore, the power that the highest order is carrying is defining the degree. So this is 6 order first degree. Let me give you one more. Let me give you guys one more. Oh, we have 5 minutes. Please, I'm sorry I had to extend your time. Please forgive me. So let's take one more shot. What about this class? We have the 5y over the T5 minus the 7y over the T7 plus 8y equals 0. What is this order and degree?
7th order degree 1, first degree.
Correct. So this is 7th order, correct, first degree. My mind is telling me to give you one more. Thank you, Abigail. Let's take one more. Let's take one more and then we'll call it today. Let's take it one more. Take one more. Take this. How about this class? So we have the 3y over the T cube plus the 4y over the T4. Please mute yourself. Mute yourself. Minus 332y equals to 0. So what is this order and what is this degree?
Order 4 degree.
4 orders, 4 degree.
Correct. You guys are very correct. This is 4th order, 4th degree. Thank you. God bless you. Thank you, Abigail. You guys are wonderful. Okay. What I'm going to do, hold on, please. Let me